Hello friends, welcome to this introductory session on information and network security. It's a 7 SEM subjects for information science and engineering. The subject code is BIS703. Hi, I am Dr. Sandeep, uh, subject teacher for information network and security, welcoming you to this introductory session. The information and network security is for the 7th semester. The course code is BIS703, and the lecture is for 4 hours every week, and total hours of pedagogy is 50 hours, 5 modules, 50 hours, so on average 10 hours per module. So the credit for this course is 4. The internal marks, the continuous internal evaluation is for 50 marks, and the semester end exam marks is for 50. That makes total of 100. The semester end exam is for 3 hours, and the examination type is theory. So the objectives of this course is to understand the basics of security, its principle, and the cryptography, to study various cryptographic algorithms available and understand the pros and cons of each of these algorithms, and see which situation, what type of algorithm will be best suitable and all that, and to apply the knowledge of cryptography to various fields for providing security, to understand and apply hash functions. So hash functions are one of the important functions that used under cryptography, and we just look at what hash functions are, and try to understand them and see how they are applied in cryptography, and finally discuss about the various key management scenarios where this information security and network security is of importance. The course outcomes: at the end of the course, the student will be able to understand the basic concepts of security and cryptography. Secondly, the student will be able to apply different hash functions for the security purposes. We'll be able to describe the random number generation and cryptographic protocols. So random number generations are one of the key aspects of cryptography, and we'll be able to explain the key management scenarios, and then we'll be able to apply the concept of cryptography for more security in different fields. So these are the course outcomes. So at the end of the course, the student will be able to have equipped with these 5 outcomes. So coming to the security, so we are mainly worried about the information and network security. In this, we are only worried about the digital world. So what exactly the security in the digital world means? So in the digital world, the security has got 3 issues. One is about the confidentiality. So that is the ability to keep the data secret. And the second one is the integrity. So it's to ensure that the data isn't altered. So it is what we call integrity, that whatever data we have in our system is not tampered or modified by any one. And the availability, so making sure that the systems are always accessible, so not that sometime it is available, sometime it is not available. So when we are talking about security in this digital world, we need all three together. That's a Venn diagram shown here, which is made up of three components: the confidentiality, then the integrity, and the availability. So the green region is the one which says that it should have all three together. This one says that the data is confidential, but not guarantee that it will be always available, or it will be is not altered or not corrupted and all that. So if we are in this part, then we say that the data is confidential, but we are not sure that it is always available, so it can be unavailable or it can be corrupted also. If you look at the integral part of that, then as long as we are in this region, the data are integral. That means there is no tampering, alteration, and all that. But we don't guarantee that it is always available, and also guarantee that it is highly confidential or the confidentiality is maintained. It may be disclosed or it may be unavailable, but we guarantee that the data is not tampered. On this side, we ensure that the data is always available, but we can't guarantee about the confidentiality of the data that may be disclosed, or we can't guarantee that the integrity of the data, or it may be corrupted. So these are various possibilities. So it's just confidential, then we can't guarantee about other two. Integrity of the data is there, then we can't guarantee of the other two. If only availability is there, we can't guarantee of the other two. But what we require is all three to be confirmed simultaneously. So that's a green region we are interested in. So if you are talking about anything called security, then we must ensure that it is confidential, it is integral, and it is always available. Then we need to understand who are our enemy in case of digital data. So we need to understand the various types of attacks possible. So it may be phishing. So phishing is one type of attack where fake emails are sent to steal the passwords. So in this case, an attacker is sending a email to the user, and of course it is a fake email, and says to click on some link, and once the link is clicked, the information from the user, all of them are automatically transferred to the attacker. So that is what phishing is, and always it is being advised not to click if the sender is unknown. Any links are there which you get from email or messages, and if the one who is sending is not known to you, have any confusion, make sure not to click on any such links. So that may be phishing. Second thing is man in the middle type of attack where someone intercepts our data while we use public Wi-Fi. So nowadays, most of the places to attract customers like hotels, hospitals, uh, such places to attract the customers, they provide free Wi-Fi and all that, and through this Wi-Fi, they may be making some type of attack where the user tries to connect to some web application. So instead of direct connection, our this Wi-Fi which we are using in the public domain may pass it all the information via the attacker. So a man in the middle attacker. So a new connection is made between the user and the attacker and the web application. So for the user, it appears as if interacting with the web application. So this web application may be some bank website or something. So the user thinks that he is using with the bank, but in reality, all the data is being passed through the middleman, and all the information like the account number, password, and all those details are on the way made known to the attacker. And this is a man in the middle type of attack. And the other type of attack is ransomware, where the attacker uh, will have control over our resources and logs our resources and then ask for money to release the resources. Like the system, the attacker will hack our system and freeze all the resources in our system, and then will ask for ransom to release all the resources. So that's another type of attack we have. Then we have distributed denial of services, who floods a server so that it crashes. So there is a server, and the attacker will start sending information or request to the server through various nodes simultaneously. So flood of requests reach the server, and the server cannot handle so many requests. So it is possible that the server may crash. So that way it makes sure that the server doesn't respond to the normal users because it's already crashed. So that's another type of attack. Then to overcome these problems, we do use something called cryptography. And here, the cryptography, what we do is to process one at the input side and one at the output side. So when we are sending message from a sender to the receiver, then at the sender side we have a process called encryption, and then the encrypted data or the cipher text is transferred on the media, and at the receiving end the message is converted back to the normal data. So that process of converting encrypted one back to the normal is decryption. And once it is decrypted, then the original data is available to the receiver. So sender will send a data after encrypting, and this encrypted version will go through the media, and then finally it will be decrypted at the receiver end, and the receiver will get the real message. The important aspect here is both encryption and decryption are under control of some uh, thing called key. So there is one key to encrypt and there is one key to decrypt. So it's something like a locker. So we put our document into the lockbox and then apply a lock to that. So, so to close the box, we do require a key which we call the encryption key, and the closed box, locked box will be traveling all the way from the sender to the receiver. At the receiver side, another key is used to open the box, and once it is opened, then the data sent from the sender is made available. So that's a logic of cryptography. So there is one process called encryption at the beginning, and there is another process called decryption at the end. So for encryption, we require one key, encryption key. For decryption, we require one key, which we call decryption key. And these two can be same or can be different. If they are same, then we call it a symmetric cryptography. And if they are not same, then we call that asymmetric cryptography. In symmetric cryptography, both encryption decryption keys are same, and before the communication begins, the sender and the receiver will sit together and decide upon what key should be used for encryption and all that. So that's they share the key for encryption, and the same key will be used for decryption. So that's what symmetric cryptography is. There is another one which is asymmetric, where the two things are different. That means there is one key for encrypting the data, and we have another key for decrypting the data. So the other key is with the receiver. So anybody can become a receiver, but only one will be sender for any particular data. One will be sending, and anyone can be receiving. So if multiple receivers are there, then each one may be allowed to receive, provided that receiving end has that receiving key. So there is one key which is sending key, there is another key which is receiving key. The sending key is only known to the sender, and the receiving key is decided by the sender, but is known to the receiver. So it is the sending side knows the encryption key. So only sending side knows the encryption key. Therefore, this encryption key is called private key, and this one is decided by the sender and sent to the receiver in advance, that whenever I encrypt any data and send to you, you use this particular key to decrypt it. And this key is available with all the receivers who wants to communicate with this particular sender. Therefore, it is in public domain, so it will be available with everyone. So we call this a public key. More details to follow in this whole subject. That's a briefing I can give at this instant. So what are we going to learn in this course? So in this course, we are going to learn how passwords are stored securely using something called hashing, how online payments stay safe using the SSL and TSL protocols, what is VPN and firewalls really do, how to detect and respond to intrusions, very important thing. So first thing is how to detect if somebody is entering into our secure line, trying to intrude into our secure system, how to detect it, and once detected, how to respond to that. So in all, we have 5 modules in this subject. So let's just briefly look what each module consists of. So in the first module we have introduction, which talks about classical cryptography, which earlier was being used, is still relevant today. So sometime back, maybe in the time of world wars and even before that, there was a habit of sending messages in a coded form, so which we call classical cryptography. And are they still relevant, or they have gone outdated? If so, what to do? If they are relevant still, how much they are relevant, how they are relevant, and all that. Some detailed study on that. And next thing is there are two issues connected with cryptography. One is algorithm to convert the plain text into cipher text, or normal data to coded data, and other side coded data back to the normal data. So their algorithms are there, and each algorithm is going to use key for making it more secure. So there is an algorithm. Along with algorithm, there is a key. Both together will decide the version, how the encoding is done, how uh, crypto, cryptography is done, how this cipher data is created, and all that. So the question is, should we keep both the things secret, algorithm as well as key? Then we realize that if key is kept secret, almost everything of the security can be achieved. Then we can keep the algorithm as a public domain, so anybody can understand what algorithm is being used. But unless until algorithm plus that key are used together, the decoding of the coded text is not possible, or deciphering is not possible, or decrypting is not possible. So for that, key is essential. So we can make sure to have some standard algorithm for conversion, but this algorithm will use key for creating the final version. So the algorithm plus key will decide the cipher result. So just key, if it is maintained secret, then it makes sense. So we don't have to keep the algorithm secret. So we can just keep the key secret. So the advantage of this is we can just have to communicate with the keys. So the protocol will consist only about the key. We have already decided what algorithm to be used for coding and decoding, for encrypting and decrypting, and all that. The next thing is to understand crypto analysis. That means how to analyze how best the cryptography method is, or encryption method is, and all that. So it can be done in some intelligent way. So we can just try to decrypt it without having the key and all that, through some trial and error, but an intelligent version, or brute force, try all possible things and then try to get it. So just look at the relationship, or what exactly crypto analysis is when it compares to decrypting through brute force. So that's all in the module 1. Then we look at the history about the cryptography, and then taxonomy about the cryptography. Getting to the module 2, we make use of hash functions. Hash functions play a major role in the cryptography. So we try to understand what hash functions are and what type of hash function will make it a good one for our purpose, and to understand the limitations of the hash function, and beyond that we just try to understand the collisions created by the hash functions. For that, just try to understand through an example, birthday paradox. Then we try to understand the difference between hashing and encryption. So for encryption, randomness is most important. If it is not random, then anybody can decrypt it easily. So to make sure that the decryption is not easily possible, there has to be some randomness. And for that randomness, we do require random numbers. And for random numbers, we require something to generate these random numbers and all that. So details about random numbers and randomness in reality is different thing, but when it comes to networking security and all that, at one side we have encryption, other side we have decryption. The key we would like to be a random one, but make sure that the same key is required on the other side. So generating two same numbers through random generation is impossible. Therefore, we have some way out that is in reality not a random number generator, but when you look at the two different numbers coming one after other, or a sequence of numbers, if you look at when it's generated, you don't find any relation between first number and second number. But though in internally there is a relationship between first number and second number, but the number which is out of the black box, so they appear as if the numbers are random to one another, so there exists no relation between one number, next number, and all that. So to create that black box where internally they are somewhere related, but externally looks something unrelated, so we do use something called random number or pseudo random generator and all that. So these are what we are going to look in uh, next session. Then how to hide the information, some techniques to hide the information. Then yes, random number generator, what we discussed. So random numbers are required for key to have a better security. The key should be random in nature. That key is random, then we need to generate random number, and that random number should be such that in the next time you should be able to generate same random number, so that at the encryption, at the decryption, you should need the same random number, then it should be possible to get it. So there is something called a pseudo random generator, which is a black box. Inside the black box, there is relation from one number to the another number in the series, but outside the black box it appears as if they are totally random to one another. And this is a one which is required to make sure that the security is well established. And then we look at something called authentication. So whenever a user wants to use some resources or any file or anything, then we must ensure that the user is correct one to use it. So there is proper authentication is required. How this authentication is to be done and all that, some details And then there are various protocols available for cryptography. So depending on different situations, different protocols are defined. So we'll just look at the various types of protocols available and see which type of protocol is useful at what type of situation and all that. So all these are the issues to be discussed in module 3. Module 4 talks about the public key management, where we just discussed that there is asymmetric encryption system, where for encryption there is one key which we call private key, which is owned by the owner of the document or owner of the resource or owner of the data, to be precise. So locks the data using the private key. Only the owner of the data knows it, but the data can be decrypted with another key, which is what we call public key. So this public key is made available to all the users who are supposed to receive the data from this particular sender. So every sender will have their own private key, and every sender will send a public key to the users who are authorized to receive the data. So when a user A wants to send to user B, then user A locks the data or encrypts the data using user A's public key. This encrypted data is transferred to user B, and user B will already have the public key of A, and using the public key of A, the user B will decrypt the data received from user A and gets the decrypted version of the file. In the other way, if B wants to send to A, then B will encrypt it using the public private key of user B, sends to A, and A is authorized user of that data, then A will be already sent the public key of B. If A is not authorized user of this particular data, then A will not have the public key of B. If A does not have public key of B, then A cannot decrypt this file, because to decrypt this file, public key of B is required, which is not available with A. But if A is authorized to use this data, then B would have already sent the public key of B to A, and this public key of B is available with A. So when the encrypted data reaches A, then it can use the public key of B and decrypt it. So that's what public key is all about, but it's not that easy as just described here. A lot of issues are involved in that, so we need a lot of things to manage here. So module 4 is all about how to manage this public key and all that, because it is made public, therefore there is very much possibility of say that the security may be breached. So to ensure that public key is available only to the authorized, many issues are to be taken up. So that's what we have to look at in module 4. In module 5, we look at various applications of the cryptography. So anywhere where digital data is traveling today, yes, there is danger of being trapped. There is danger of being overseen. There is danger of being corrupted. Lot of dangers are there, lot of attacks are possible. To make sure that none of these things happen to any data which is transferred onto the public domain, like internet or whatever such thing, or even putting on the cloud and all that. Make sure that the data is properly encrypted before transmitting, properly encrypted before storing somewhere, and when you are trying to use it, we need to decrypt and use it. So what all applications the cryptography is required? So in what all applications we do have information security problem, network security problems, and just look at them and see in each of these problems what type of cryptography comes to our aid and all that. So that's all we look at module 5. Looking at relevance in the real life and the careers. So cyber security is not just a technical skill, it's a global need. So whether you want a job or you want to live, yeah, we do work in the digital domain, and almost all our lives are digitally connected. So as long as we are secure digitally, it is difficult to survive. So it has become a global need. So cyber security has become a global need today. So as a career, if you look at it, then we can uh, become a penetration tester. So just look at how strong our system is created. So how much any attacker can penetrate into our system. So that's just to verify how best our security system is built. So to verify the efficacy of our security system, we do have some specialized people who just keep checking our security system, which we call a penetration tester. Then we can have security analyst, then a cryptographer, which they is going to keep on defining new types of algorithms and many such things. So that's what we are going to see in this semester, subject information and network security. So hope we are going to enjoy this journey, and make sure to have a better information about what attacks are possible under cyber world, what cyber crime is, what the problems anybody can face in the digital world, so that as a cyber engineers we can make sure that everyone's life is safe under the digital world. So welcome to this cyber world, and let's get into more details in this semester, and hope you enjoy this journey. Thank you.